I really don't know how to sugarcoat this, so I'll say it up front. AI agents are a scam. Personally, I think if you're looking for agents to eliminate tasks and reduce headcount, you're heading in the wrong direction. That's because agents are the least reliable, most expensive, and amateurish way to run a production workload that's ever been invented. The AI industry is selling them to you anyway because every agent burns tokens, and tokens is how they get paid. So in this video, I'm going to go back to software first principles and explain how serious software actually runs. I mentioned this in the previous thought experiment video about eliminating windows. And that's because the gold standard for software distribution is the compiled binary. In simple terms, that means it's software that's been translated directly into the machine instructions for a specific chip. It's designed to run on that chip and that chip only. And that means the processor runs exactly what's written, and there's no interpreter sitting in the middle. There's no runtime guessing what you meant, and the same input produces the same output every time on every machine with the same architecture. That means I can write code here on my MacBook Pro and know that everybody with exactly the same computer, it will run exactly the same way. That's how your operating system runs. That's how your database runs. That's how the firmware in your car runs. Because when the stakes are real, we ship binaries. A binary is fast because it's native. It's reliable because it's deterministic. And it's cheap because it does the work and gets out of the way. So if you want a workload at scale, you need to build as close to the binary as you possibly can. Now that's ideal, but it's not always possible. You might have different types of hardware and you can't afford to replace everything. So you need to start making a compromise. And that's where containers come in. Containerization is a strategy which wraps your code with its dependencies and runs it in an isolated environment. It's still compiled code in most cases. It's still deterministic, so you know what you'll get out the other side, but now you start to pay a small tax in terms of performance and complexity so you can move it across similar machines. Things like Docker, Kubernetes, all that infrastructure exists because we accepted a little overhead in exchange for being able to move things around. The problem with containers is they have a cold start. They don't start up straight away, and then they consume memory themselves, and every instruction must go through an orchestration layer. But the work itself is still being done on native code, and the behavior is still predictable. It's acceptable engineering, and most of the modern cloud runs this way. If you take a step back again, this is where interpreted languages and scripts come in. Things like Python, JavaScript, Ruby. The code is not compiled to machine instructions ahead of time. Instead, an interpreter reads the source code at runtime and decides what to do with each line. This is where you start paying a serious performance tax. Python can be 100 times slower than C for most workloads. That means most of your processing power is spent interpreting and translating your code, not running the actual logic. Every variable will go through a dictionary to check its type, and this way it's very easy to introduce bugs and failures along the way because quite literally, it's making up the instructions as it goes. Now, the good thing is that interpreted languages are still deterministic. You give them the same input and you get the same output, but you're paying 100 times more for the same work compared to the gold standard. Now, we tolerate this because developers are expensive and Python is fast to write. And then at the bottom of the reliability ladder, we have the AI agents. The AI agent is the worst of all these options. And the fact that the AI industry is pumping them out so hard goes against every fundamental design principle that the technology industry has been working towards for years. When you ask an agent to do something, it does not execute instructions. It asks an LLM to interpret the markdown to write some code, which it will then execute. And because LLMs are inherently probabilistic, the same prompt will produce different outputs on different runs, which means the same task could take a different number of steps. The workflow that worked yesterday might not work tomorrow, and you'll never have a clue why. This is not a serious programming technique. It's the infinite monkey theorem dressed up as software. If you bash enough keys and burn enough tokens, eventually you might get the consolidated works of Shakespeare. I seriously shake my head when I hear people talk about agents. A native binary runs a task in milliseconds for a fraction of a cent of electricity. An interpreted Python script can run the same task in tens of milliseconds for a slightly larger fraction of a cent. A containerized microservice can add a little bit more overhead on top of that. But an AI agent doing the same task can burn thousands of tokens, and it can take 10 to 30 seconds and cost you 1 to 50 cents per execution. And it might be wrong, and you have no way of knowing in advance whether this one will run or this one will fail. You're paying 1,000 times the compute for 1,000 times less reliability, and that is a scam. Every layer of abstraction the AI vendors add between your business logic and the silicon is a layer for them to charge you money. Agents are the most profitable abstraction ever invented because they consume tokens in proportion to how much they fail. That means the worse they perform, the more you pay. While the rest of the industry is building bigger and bigger, I'm building smaller and smaller. The Kiraa AI I'm building is as close as possible to the binary as I can get. And that's so it stays fast, cheap, and most importantly, it stays secure. So my advice is use agents to learn and to prototype. They're great fun for home projects and for fleshing out business logic. But when you're serious, you need to build as close as possible to the binary. The further you drift from that, the more you're paying for someone else's margin. That's the discipline, because everything else is just AI theatre. I'm Dr. Errol Brandt, the founder of Kiraa, and I'd love to hear your thoughts about this approach in the comments below. Even if you're a big fan of agents and you think I've got it all wrong, I'd love to hear your perspective. Thanks again, and I'll see you in the next one.